So in this lecture we will discuss method of partial fraction. Method of partial fraction. So in this lecture we will discuss method of partial fraction. In this method there are two types of rational function. Rational functions. We have two types of rational function, p of x upon q of x, where p and q are some polynomials of x. So there are two types of rational function. One is proper rational function, and another is improper rational function. Improper rational function. In difference of these two, proper rational function and improper rational function. If degree of px, degree of p of x is less than degree of q of x, then it is known as proper rational function. In that case, p of x upon q of x is a proper rational function. So in a proper rational function, degree of p of x is always less than, strictly less than degree of q of. As for example, x plus 1 upon x cube minus 1. This is an example of proper rational function. You can observe in numerator degree is 1. Here numerator degree is 1, in denominator degree is 3. So this is an example of a proper rational function. Another example, say x square plus 1 upon x minus 1, x square plus 4. This is also an example of a proper rational function. Here you can observe degree of numerator is 2 while degree of denominator is 3. So this is also an example of proper rational function. Another example, 5 minus 3x upon x cube plus 3x plus 2. These are all examples of a proper rational function in which degree that is power, degree of numerator is always less than degree of denominator. So that is called a proper rational function. But if degree of p of x is greater than or equal to degree of q of x, then it is known as improper rational function. Then p of x upon q of x is improper rational function. Degree of p of x is always greater than or equal to degree of q of x. In that case, it is known as improper rational function. As for example, x square plus 1 upon x plus 3. Here you can observe in numerator degree is 2 while denominator degree is 3, or say x cube plus 1 upon x square minus 2x plus 1. This is also an example of improper rational function. So there are two types of rational function, and one is proper rational function, another one is improper rational function. We assume that proper rational function is given. If improper rational is given, then one can express as improper rational function can be written as sum of polynomial plus proper rational function. And this method to express improper rational function as sum of polynomial plus proper rational function, that is known as method of partial fraction. So by actual division or by rearrangement of numerator, one can express improper rational function, for example, as a sum of polynomial plus proper rational function. For example, x cube plus 2 upon x plus 1. So you can observe this is a improper rational function because degree in numerator is 3 while degree in denominator is 1. So this can be written as x cube plus 1 upon x plus 1. So this we can write actual division is also possible. Divide x cube plus 2 by x plus 1. Now x cube plus 1 can be written as x plus 1 x square minus x plus 1 according to factor of a cube plus b cube. X cube plus 1 can be written as x plus 1 into bracket x square minus x plus 1 plus 1 upon. Now divide each polynomial by x plus 1. So this is x square plus 1 upon x plus 1. So this you can observe it is nothing but polynomial plus proper rational function. So in this method we will discuss how to solve the problem by partial fraction. So for that purpose we will assume that proper rational function is given. If improper rational function is given, then first we will express as polynomial plus proper rational function. So there are main 4 cases. Case 1, now we assume that proper rational function is given Case 1, first we have to factorize the denominator. Suppose x plus 1 upon x plus 2 x plus 3. This type of proper rational function is given. Here you can observe degree of p of x is less than degree of q of x. So this is proper rational function. Now in denominator factors are given. If it is not given, then first you factorize the denominator. In case 1, in denominator factors are linear and non-repeated. So in denominator we have factors in which are linear and non-repeated. So to solve this by method of partial fraction, you have to write expression of the form a upon x plus 2 plus b upon x plus 3, where a and b are constants to be determined. So again, case 1, in denominator we have factors which are linear and non-repeated. So now find out unknowns a and b. For that purpose, take LCM. A into x plus 3 plus b into x plus 2. You take LCM both the sides. Just we have taken LCM, sorry. Now, if this is identity, then it must true for all values of x. Put x equal to minus 2. Say here, if we put x equal to minus 2, then denominator will be 0. So one value is x equal to minus 2. Similarly, next value will be according to this. To make denominator 0, one value is x equal to minus 2 and another value we will take x equal to minus 3. So here, when we put x equal to minus 2, 1 equal to minus 2 plus 3. A into minus 2 plus 3, and therefore a equal to 1. You can observe a equal to 1. Next, put x equal to minus 3. So when we take, here we have committed a mistake. This is x plus 1. Again rewrite this thing. Take LCM. So x plus 1 equal to a into x plus 3 plus b into x plus 2. Put x equal to minus 2. So minus 1 minus 2 plus 1 equal to a into minus 2 plus 3. Therefore a equal to minus 1. You have to select value for x in such a way so that denominator of a or b becomes 0. So first we take x equal to minus 2. So denominator of a will be 0. After taking LCM, once we take x equal to minus 2, and then when we take x equal to minus 3, we will get value for b. Now put x equal to minus 3. So from this equation, when we put x equal to minus 3, left hand side minus 3 plus 1. So minus 3 plus 1 a into, here when we put x equal to minus 3, denominator will be 0, minus 3 plus 2. Therefore minus 2 equal to minus b. So finally we will get b equal to 2. So here when we take b equal to 2 and a equal to 1, x plus 1 upon x plus 2 into x plus 3 equal to a upon x plus 2 plus b upon x plus 3. So once we put value for a and b, x plus 1 upon x plus 2, x plus 3, a that is minus 1 upon x plus 2, b that is 2, 2 upon x plus 3. Now you can note the advantage of this method. Say left hand side it is not integrable. So when we integrate this with respect to x, so when we resolve it into a partial fraction, you can observe right hand side is integrable, left hand side there is no formula to integrate. So once we use method of partial fraction, right hand side is integrable. Right hand side easily you can integrate minus log mod x plus 2 plus 2 log mod x plus 3. So this is case 1 in which we have in the denominator factors which are linear and non-repeated. So first you only note the expression how to write right hand side. Total there are 4 cases. Case 1, you take general example, x plus 1 upon x plus 2, x plus 3. Second one, in denominator we have x plus 2 square, x plus 3. So we discuss 4 cases. In the next one we will discuss how to find unknowns on the right hand side. Third one is, say x plus 1 upon x square plus 1, x minus 1, and fourth one is, normally we will not use this case, but only you should familiar with right hand side expression. X plus 1 upon say x square plus 2 square and x plus 3. So first you observe all these 4 are proper rational function in which degree of numerator is less than degree of denominator. Now right hand side expression is not the difference. In case 1, denominator factors are linear and non-repeated. Here combination of repeated and non-repeated. This is non-repeated while square means 2 times. So you note the difference. Here we will write right hand side expression of the form a upon x plus 2 plus b upon x plus 3, and you can extend this right hand side expression if in denominator you have more factors. Suppose in one more factor x plus 4, you can expand this plus c upon x plus 4, where a, b and c are constants to be determined. Now right hand side for second one. Second one, in denominator x plus 3 factor is linear and non-repeated, while x plus 2 squares, due to square it is repeated, and since x plus 2 so it is linear. So for non-repeated we will put a upon x plus 3. Now for repeated, b upon x plus 2 plus c upon x plus 2 whole square, where a, b and c are constants to be determined. So this is the expression on right hand side in the case of when we have in denominator we have roots which are linear combination of repeated and non-repeated. Now in third case, in denominator x square plus 1 which is quadratic and irreducible. Irreducible means you cannot get real roots. X square plus 1. We are not discussing imaginary roots. For x square plus 1 it is irreducible. So if it is irreducible, 1 a upon x minus 1, this is due to x minus 1 which is linear non-repeated according to case 1. But for x square plus 1 which is quadratic and irreducible, so we will write in numerator bx plus c upon x square plus 1. So this is the expression in numerator in the case when in denominator you have quadratic and irreducible. Now here quadratic and repeated, so for that one a upon x plus 3 bx plus c upon x square plus 2, and this actually this case will not in the our syllabus, but in such a cases here we have to factorize denominator, then we can integrate. For that purpose we are not discussing at present, this case we are not discussing. So only we will consider three major cases. In denominator when you have irreducible polynomial which is repeated, we are not discussing at present. Now how to find unknowns a, b and c. For example, suppose we want to integrate x plus 1 upon x plus 2 x plus 3 square. Now first we have to resolve this by partial fraction. So for that purpose a upon first factor is linear and non-repeated. Now we take care, x plus 3 square is there, so it is linear and repeated, so x plus 3 square. So this is the expression in the case when you have roots which are linear and repeated. So linear and repeated, if you can expand, suppose you can expand this. Suppose you have x plus 1 upon x plus 2 x plus 3 cube. Then you have to write like this, a upon x plus 2 plus b upon x plus 3 plus c upon x plus 3 square d upon x plus 3 cube, where a, b, c, d are constants to be determined. Now how to find a, b, c? First we take LCM, so x plus 1 equal to a into x plus 3 square plus b into x plus 2 x plus 3 plus c into x plus 2. So when we take LCM, both this, so right hand side denominator, left hand side denominator we can cancel. So when we take LCM, x plus 1 a into x plus 3 whole square b into x plus 2 into x plus 3 plus c into x plus 3 c into x plus 2. Now to find unknowns a, b and c, we will take one value x equal to minus 2. This is the value because due to this denominator of a will be 0. Another value will be x equal to minus 3. Using these two value, you will get two constant out of 3, a, b and c. So first now we are discussing method how to find unknowns a, b and c. Now taking x equal to minus 2, so minus 2 plus 1, here a into minus 2 plus 3 square, remaining term will be 0 when we take x equal to minus 2. So a equal to minus 1. So a equal to minus 1. Solve this equation, you will get a equal to minus. Now next value is take x equal to minus 3. So left hand side minus 3 plus 1. This term will be 0. This term will be 0 when we take x equal to minus 3. C into minus 3 plus 2. Take x equal to minus 3. So when we simplify this one, minus 2 equal to minus c, minus 3 plus 1, that is minus 2, and right hand side minus c. So c equal to 2. So out of 3 unknowns a, b and c, by taking two values easily you will get value of two constants. Now to find remaining constant, we have obtained value for a, we have obtained value for c. Now third one, using a and c you can get value of remaining constant b. Another method is, to find unknown b, one, put x equal to 0. This is one method. Method 1, in which we will put x equal to 0, or you can say that equating constant term. Now another method is equating coefficient of x square both sides we get. So when we compare coefficient of x square, left hand side there is no term containing x square. So coefficient of x square is 0. Here when we expand this one, coefficient of x square will be a. In second term, coefficient of x square it will be b. So a plus b equal to 0. When we compare both side coefficient of x square, you can also compare coefficient of x, you can also compare constant term. In any case you will get value of remaining unknown. Here we have compared coefficient of x square. So again you note that left hand side there is no term containing x square, so coefficient is 0. Here when you expand this, a into bracket x square plus 6x plus 9, so coefficient of a it will be x square, coefficient of x square it will be a, so this is a. B into x plus 2 into x plus 3, when you expand this you will get coefficient of x square as b, so a plus b, and in third term there is no term containing x square, so coefficient will be 0. So a plus b equal to 0, so b equal to minus a, put value of a which is minus 1, so reason is a equal to minus 1. Thus we have obtained value of b equal to 1. So this is the method in which in denominator we have linear factors and which are repeated. So now you can observe, in place of integrating x plus 1 upon x plus 2 into x plus 3 whole square dx, we will use this expression by substituting values for a, b and c. So a equal to, now a equal to minus 1, so minus 1 upon x plus 2, b equal to 1, so 1 upon x plus 3, 1 upon x plus 3, and c, that is 2 upon x plus 3 square dx. Now you can observe right hand side easily integrable. Term wise you can integrate minus log mod x plus 2 plus log mod x plus 3, and last term is x plus 3 raised to minus 2, so integration is 2 into x plus 3 minus 2 plus 1 upon minus 2 plus 1 plus c. So right hand side easily integrable. You can observe the benefit of this method. Left hand side there is no formula to integrate. Once we resolve it into a partial fraction, term wise one can integrate. So this is the advantage of method of partial fraction. So in next lecture again we will discuss this method as a revision one.